Question 9 is kind of similar to question number 5 in this section, right? It's that function notation again. There's a few more steps this time. The equation's a little weirder, but it's the same thing. So we're just going to make sure that we follow instructions. And again, just like with number 5, we've got to make sure we understand what the instruction is. So in this case, we've got these two pieces here, h of 5 minus h of 3. But really, that's kind of two steps combined into one. So first, we would just do what is h of 5, turn that into a number. That's an instruction that's separate from the 3. Just do that instruction first. H of 5 means that we replace our x with a 5. That's all that function notation means. This 5 is in place of x, so we put the 5 in place of the x. That's it. So 2 to the 5th, we have a calculator, so we could definitely do that in our calculators, but we could also just kind of multiply 2's until we get there. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 one more time is 32. So there you go. And then let's do a different color for the h of 3. New instruction, new number, but we still put it in the same exact place. Now it's 2 to the 3rd, which hopefully we know is 8. 2 times 2 times 2. And then the final instruction, the one that really we don't want to mess up here, is just we subtract the 2. So h of 5 minus h of 3, we're just replacing the values that we found for each of those things and doing the subtraction. So 32 minus 8 is 24. So choice C is our answer here. So one thing that people tend to mess up on function notation questions is they like to do like the subtraction first, or they like to do the substitution first. My advice is just treat each of these little function things as its own problem. You solve that problem, you get an answer. You solve the next problem, you get an answer. Then we take the two answers and subtract them. It's a little easier if you can kind of narrow your focus and break it up, but ultimately we're just kind of doing PEMDAS, following instructions, turning this weird notation into just normal arithmetic so we can solve. That's all that function notation is.